Every black hole you've ever seen in a movie, a textbook, or a NASA simulation might be a lie. For a century, we've been told that at the heart of these monsters lies a singularity, a point of infinite density where space and time simply stop existing. But in the world of physics, infinite is almost always a code word for we're wrong. What if the most famous objects in the universe aren't actually holes at all? The standard model of a black hole is a mathematical catastrophe. Our current equations say they pack the mass of 10 million suns into a space of exactly zero volume. If that sounds like nonsense to you, you're in good company. Albert Einstein himself spent years trying to prove that black holes were impossible. He believed nature would never allow such a bug in the code of reality. To understand why this matters, think about the information paradox. If you fell into a traditional black hole, every atom of your being, every memory, and every bit of data would be deleted from the universe forever. This violates the most fundamental law of physics, that information can never be destroyed. We are currently staring at a glitch in the cosmos that suggests we've been misinterpreting the event horizon for 100 years. In our normal understanding of the universe, gravity is the undisputed heavyweight champion. When a star 3 times the mass of our Sun runs out of fuel, it collapses. Gravity crushes the atom so hard that the electrons and protons merge, then even the neutrons give up. This is what should happen. According to general relativity, the collapse never stops. It creates a bottomless pit in the fabric of spacetime. This pit is surrounded by the event horizon, the point of no return. Anything that crosses it is gone. But this model forces us to accept the singularity, a place where gravity becomes infinite and the laws of physics are tossed out the window. It is the only place in the universe where science admits it is totally blind. But a radical new theory suggests we aren't looking at a pit, but a bubble of dark energy that is harder than any diamond in existence. By the end of this video, you'll see the evidence that black holes might actually ring like a bell. If you want to be here when we finally rewrite the textbooks, subscribe now. We're going inside the Gravistar. In 2001, 2 physicists, Paul Mazur and Emil Motola, decided that the singularity was a bridge too far. They realized that we already know of a force that can fight gravity on a universal scale, dark energy. Dark energy is what's currently pushing the entire universe apart. Mazur and Motola asked a mind-bending question: what if, as a star collapses, the spacetime inside doesn't fall forever, but undergoes a phase transition? Imagine liquid water suddenly flash freezing into a solid block of ice. They hypothesized that the interior of a collapsing star could turn into a vacuum bubble of dark energy, creating a gravitational vacuum star, or gravistar. The core reality is this: a gravistar is not a hole, it is a hollow shell of ultradense matter. Imagine a bubble of dark energy that pushes outward with so much force that it perfectly balances the crushing weight of gravity. Instead of an infinite pit, you have a physical, solid surface. Think of it like a frozen soap bubble in space. This shell would be made of a Bose-Einstein condensate, an exotic state of matter that is incredibly thin but practically indestructible. From the outside, it would look identical to a black hole. It would have an accretion disk, it would warp light, and it would have a shadow. But if you were to fall toward it, you wouldn't fall forever into a void. You would hit a surface. This solves the information paradox instantly, because information isn't deleted, it's just smeared across the surface of the shell like data on a hard drive. But wait, it gets stranger. In 2016, the LIGO Observatory detected gravitational waves from 2 black holes colliding. For most, it was a triumph for Einstein. But for Gravistar supporters, they noticed something impossible in the data: the echoes. When 2 empty holes collide, the signal should end abruptly. But if 2 solid shells collide, the gravitational waves should bounce off the surfaces and create a repeating echo. Some researchers claim to have found these echoes in the LIGO data. Just when you thought you understood the void started ringing. However, the scientific community is currently in a state of civil war over this. Some say the echoes are real evidence of a solid surface, while others say it's just background noise. This leaves us with the ultimate question of reality. Does nature allow for a hole where physics dies, or does it prefer a bubble of dark energy that keeps the laws of information intact? I genuinely want to know, are you Team Singularity or Team Gravistar? Type your choice in the comments. I'm looking for the best argument for either side. This matters because how we answer this dictates the fate of our universe. If gravistars are real, it means dark energy isn't just a mysterious background force, it's a fundamental building block of the most massive objects in the cosmos. It means the nothingness of space is actually a lot more solid than we ever dreamed. We are living through the golden age of gravity. With the James Webb Space Telescope and more advanced gravitational wave detectors, we are finally touching the edges of these monsters. Whether they are holes or stars, we are on the verge of the biggest breakthrough in physics since the 1900s. Speaking of solid space, did you know there's a theory that the entire universe is actually a hologram projected from the surface of a black hole? We're diving into the holographic principle in the next video. Stay curious.